In this video, we're going to look really quickly at a few other reagents that can be used for the preparation of organohalides from alcohols, and then we're just going to summarize overall the preparation of organohalides. If we have an alcohol, we can treat it with HBr to form the alkyl bromide. However, while this reaction proceeds relatively quickly, this reaction is slower and this reaction is much slower. So alternative reagents have been discovered that can carry out the reaction more quickly. So an alternative to using HBr is called phosphorus tribromide, or PBr3. So instead of using HBr, you could always choose PBr3. Now, in the case of a tertiary alcohol, the reaction with HBr is just fine, so you would probably choose HBr. For a secondary or primary alcohol, because these are slower, phosphorus tribromide is probably the better approach to go. Now, these alternatives still have been developed 100 years ago. And so by now, there have been many other reagents that have been developed as well, ones that are more effective and ones that are greener reactions. So green chemistry involves the prevention of hazardous waste. And so there are newer reactions that have been developed that do not require hazardous solvents, they do not require hazardous reagents. Their byproducts are more benign. So there are many other reagents that have been developed because synthetic organic chemistry is not something that has been developed 100 years ago and then remains stagnant. There are constantly developments and improvements. However, that also means I could give you 20 different reagents that you would need to know. I'm not going to do that. I tend to stick to the classics because we're only doing this on paper. I'm giving you one alternative because some of the textbook questions or other resources might use different reagents, so I at least want you to recognize these. If we were to do this in lab, then we would use one of the newer methods, which would be safer for us and for the environment. Now, what if we wanted to convert an alcohol to an alkyl chloride? We know that we can treat these with HCl. Or we could use an alternative called thionyl chloride. This is SOCl2 and it looks like this. Because a tertiary alcohol is pretty reactive, we'd probably just stick with HCl. For a secondary, then thionyl chloride is a better option, and this is usually carried out with pyridine. Pyridine is an amine base that looks like this. So it's like a benzene ring, an aromatic ring, except that there's a nitrogen in the ring. For a primary alcohol, thionyl chloride and pyridine is really a good way to go. Once again, there are more modern reagents that are safer and better for the environment, but I'm not going to ask you to memorize all of those. Finally, when it comes to converting an alcohol to an alkyl fluoride, just treating it directly with HF isn't effective, but if it's treated with HF in the presence of pyridine, then this reaction can proceed. So the same reaction conditions could be used to convert tertiary, secondary, primary, or methyl alcohols to the fluoride. So finally, let's summarize what we've seen for the preparation of alkyl halides. If we react an alkane with a molecular halogen, and this works best with chlorine or bromine, this must be carried out in the presence of light and heat to give us an alkyl halide. Remember, the presence of light and heat is required to generate radicals from molecular chlorine or molecular bromine, and then this proceeds through a radical mechanism. It's important to remember the details of the mechanism so that you know what products are expected. Remember that with chlorine, it is very reactive, but not very selective. And so you tend to get a mixture of products resulting from radicals at different locations. And so this reactions work best where you have equivalent hydrogens that can be abstracted. Bromine is not very reactive, but it is more selective. So reaction with bromine will primarily occur to give you the tertiary alkyl halide, which results from a tertiary radical. Another way to prepare alkyl halides is starting with alcohols and reacting them with HX. And we want to keep in mind that tertiary and secondary alcohols will proceed through the SN1 mechanism, which goes through a carbocation. Primary and methyl alcohols will undergo the SN2 mechanism, where there is no carbocation. We also want to remember the alternatives, which would be to use phosphorus tribromide to make alkyl bromides or thionyl chloride to make alkyl chlorides. Now, I also want you to think about having a synthetic toolbox. So you are just beginning to get some tools. You're just beginning to recognize that here's a way to make an alkyl halide. Here's another way to make an alkyl halide. So right now you have a hammer and you have a saw in your toolbox. It's very important that you know the details of how to use your hammer and how to use your saw. But you don't have enough tools to be able to build a house yet. So this is where you need to be patient and recognize that throughout the year, you're going to be adding more and more tools to your synthetic toolbox. So eventually you're going to know, here's a way to make an alcohol, and then from an alcohol, I can make an alkyl halide. And then from an alkyl halide, here's how I can make something else, and something else, and something else. You're going to know not just functional group transformations, such as going from an alcohol to an alkyl halide, but also carbon-carbon bond forming reactions. So you will slowly be adding tools to your toolbox throughout the entire year, so that by the end of the year, you're going to be able to carry out multi-step syntheses, which we can think of as being able to build a house.